You shall write simplifying Okay, so when we're done this, we're going to look at the key ideas in the book, and then that's it, right? And then any other examples in the book you can use as further examples of how to do this, right? So, if we want to simplify a rational expression, then we need to know, well, what does that mean, right? So, a rational expression Okay, so definition. A rational expression is in simplified form when the numerator and denominator have no common factors. So numerator and denominator have no common factors. The implication there is that we have to factor. Right, and that's really how we do the first step. And actually, it's almost the first step in almost anything to do with rational expressions is just to kind of factor stuff. So we got to start off by factoring. That's not the only thing we're doing, right? And so I'm going to give you 4 steps for simplifying a rational expression, right? So all we're going to do is follow the 4 steps. Step 1. We're going to completely factor in the numerator and the denominator. Okay, so let's write this down separately. So step 1.
No! I was like done like 3 words.
You can watch the video later.
Yeah, you get the notes offline when I can get them online, which is God knows when, but the way the internet's working today in the school system, yeah, not so much. So completely factor the numerator and denominator. Step 1 is also going to hold for the next couple lessons, right? On adding and subtracting, on multiplying and dividing rationals, right? Adding and subtracting, it's part of step 1. It's factoring the denominator, okay? But, you know, if you see a rational expression, the first thing you do is sit down and look at it, just factor everything, you're halfway to a solution. Step 2. Step 1. 2. You're going to state the restrictions from the factored form of the denominator. So remember, the restrictions are the values of x that will make the denominator 0. Actually, the non-permissible values are the values of x that will make the denominator 0, and the restrictions are saying x cannot equal that number, right? What can't x be? Now, on tests and that, sometimes you'll see the thing and it'll say x cannot equal, right? You'll be clued into what the restrictions are. You can do this question, but x can't be these values. So step 1, completely factor numerator and denominator. Step 2, before you do anything else, you have to state the restrictions. Okay, and the reason is because in step 3, you divide out the common factors. And so you want to state your restrictions before you do any cancellation, right? If you cancel stuff, you could cancel off one of the restrictions. So divide out the common factors. Divide out the common factors. So step one, get those common factors if there are any, like factor everything. Then state the restrictions. Then divide out the common factors between the numerator and denominator. So anything on the top will cancel with anything on the bottom. And that becomes important when we get into multiply divide, right? Anything, any expression that is on the top in the numerator of a rational expression will cancel with any expression that's in the denominator. And step 4 is just check. Make sure, did I do that correctly? Could I cancel them out, right? Did I cancel something that I shouldn't have been able to? Or is there something still left that cancels, right? It's like, hey, all these numbers are even. Oh, well, then I could have taken out a 2. Maybe I didn't completely factor. Okay, and then I realize that at the end when I go back to check and say, oh, hang on a sec, there's still a common factor here. All right, let's do a dozen.
Wait, is the last one?
So in increasing order of difficulty, we start with simplifying monomials. Monomial means one term. Okay, monomial, one term. And there's a couple of different strategies that we can use here. So I'll show you a couple of different ways. So let's say we have 15x squared over 10x. So what you could do is say, well, okay, is there a number that goes into both 15 and 10? 5. And at the same time, we're also going to say, well, what do they share in common, the numerator? They share an x, right? So there's one x. So I could take a 5x out of the top. I could write it as 5x times what? 3x. And on the bottom, I can write that as 5x times 2. And now you notice I have a common factor, right, which is 5x. They both share 5x, so I can cross those off. When I do, I put a 1, right? Like, term doesn't disappear. It doesn't become 0. Oh, 5x is gone. There's 0. It's just a 1 there. And we are left with 3x over 2. Now, before we did any of that, we should have said what? X cannot be 0, right? So we have to look. See, down here, x could be 0, right? Who cares? 3 times 0 is 0. 0 divided by 2 is 0. You can divide into 0, but you can't divide by 0. So we need to state the restriction right up top, saying, hey, x can't be 0. And as long as we go down here and say, if x is not 0, then these two guys will work out the same for any value of x, right? If you put x as 10 in here, you'll get 1500 over 100, which is 15, right? And here you get 3 times 10 is 30 over 2, which is 15, right? So they'll reduce to the same amounts. So that one's factoring out. Now, sometimes what we could do instead is we could just cancel in place. So you can look at this expression and its restriction, and you could say, all right, well, look, 5 goes into 10 twice, into 15 3 times. This x is going to take out the squared, so I'm just left with the 2. It's not x squared anymore, it's 3x, and we're left with 3x over 2. Okay. So you can just divide out the common factor basically in place. Okay. So you get a couple of choices. One is take out the common factor between numerator and denominator, or just divide it out in place. B. 25y squared over 40y to the 6th. Okay, step 1, factor. There is nothing to factor, right? No. Step 2, non-permissible value. What is it? Y can't be 0. Right, it's really easy in monomials, right? In monomials, just if there's a variable in the denominator, that variable can't be 0. Right? And if there's an expression in the denominator, well, an expression in the denominator means to be more than one term, right? And we're just doing monomials. Okay, how do you want to do this? Take out the common factor and then cancel them, or just do it in place? Okay, let's go with common factor. What goes in? What's the largest number that goes into 25 and 40? 5. What's the smallest power? Basically, what's going to be common between these guys is the smallest power of y. So what's the smallest power of y? Y squared. Okay, so we're going to write the top as 5y squared. Now what do I multiply it by to get 25y squared? By 5. And on the bottom, well, we've said 5y squared is our factor, right? So what's left? 8. How do we get 40? Well, 5 times 8. And how do we get y to the 6th? Y to the 4th. Okay. Common factor cancels top and bottom. We are left with 5 over 8y to the 4th. Okay, and that's probably actually the easiest way to do it. If you're comfortable canceling in place, by all means, feel free. Okay, let's do another one. We got negative 12x to the 4th over negative 3x to the 5th. Okay, restriction is x cannot be 0, right? Again, monomial is really easy, right? Because it's just one term, so it's got an x in there, then the x can't be 0. Largest number that goes into negative 12 and negative 3? Okay, so let's go with negative 3. That'll get rid of the negatives, right? So I've got negative 3. Smallest power of x is x to the 4th. Okay, so what's left? We're going to have a 4 here, right? Then multiply it out. Make sure. Do I get negative 12? Yeah, I get negative 12x to the 4th. Okay, negative 3, x to the 4th. That's going to be my common factor. And what am I left with? Just an x. And we're left with 4 over x. And remember, yesterday it was equivalent rational expressions, right? These expressions are equivalent. This expression is the same as this expression for any value of y, right? Except y equal to 0. This expression is the same as this one for any value of x. Again, except when x is equal to 0. Okay, so that's monomial. Seems easy. Let's simplify binomial. A binomial numerator. Let's do a binomial numerator. And we'll have a monomial denominator. Let's try this one. 30x cubed plus 40x squared over 25x squared. Okay, so step 1. This time there is something to factor, right? We can factor the numerator. So, largest number that goes into 30 and 40. 10. Then we go with the smallest power of x, right? They both have a power of x. The one that's common will be the smaller one, so it's 10x squared. Okay, what's left? So how do I get 30x cubed out of this? What goes here? 3x plus. Then this sign is always going to be the same, right? It's going to be a plus sign. So plus what? 4. Bless you. Over 25x squared. Okay, we factored. Now step 2 is state non-permissible value. So what's the non-permissible value? can't be 0, right? Anytime it's a monomial denominator, it's easy, right? It's just the variable can't be 0. And if there's no variable down there, then there's no restriction, right? If there were no x in the denominator, then I wouldn't be worried about that. Okay, you could put any value in. So now what we want to do is cancel here. So we got two choices. We can cancel in place, or you can just cross off the x squared, right? So an x squared there and there. What goes into 10 and 25? 5. How many times? 2. How many times? 5. Okay, so we've got 2 times 3x plus 4 over 5. That's our simplified form. Okay. As long as, again, the restriction, x is not equal to 0. There's no problem here with x being 0, right? X is 0. Okay, so that's 0. I got 4. I get 8 over 5. Okay. But you go back up top, put x is 0, you get undefined. So they won't evaluate the same. Every other value of x, they will. X is 2. What do we get? 6 plus 4 is 10. This would be 20 divided by 5 is 4. And if x is 2, we get 8. This is 240. We get 4. This is 160. 240 plus 160 is 400. This is 4. 25 is 100. So 400 divided by 100 is 4. Okay, same number. So they are equivalent rational expressions. Turn this way. All right, B. 20x cubed minus 12x squared over 16x. Okay, give it a shot. You should be able to factor the top, right? Just common factor, two terms, common factoring. All right, what goes into 20? I start with that. So what's wrong with that? As a start. I mean, I haven't done the denominator yet, but what's wrong with the numerator? It's not completely factored, right? Okay, so how do you know? Well, you look here and you go, wait a sec, 10 and 6 are both even, right? Ah, darn, I could have divided out another 2. So it's not 2, it's 4x squared. Okay, and then that's going to give me 5x minus 3. So make sure it's fully factored, right? What are the steps? Fully factoring. Last step's always to check it. So make sure this expands back out. 20x cubed minus 12x squared. Okay, that expands back out. But, if I have a common factor still in here with the 10x and the 6, oops, get out the eraser. Clean it up. Okay, x cannot be 0 again, right? Okay. We could write this as 4x times x times 5x minus 3, and we could write this as 4x times 4 if you wanted to, right? We could pull the factor that's common between these guys out. So that's one option. So let's do it. So let's say, so I recognize, okay, 4x goes into here, 4x goes into here. So that'll be 4x, will be an x here, and a 5x minus 3. And this will be 4x times 4. Okay, wait, let's write the 4x in brackets. So these are the guys that are going to cancel. Okay, so your final answer is x times 5x minus 3 over 4. And we don't expand this back out again, right? So once we factor something, we don't go and expand it back. We just leave it as x times 5x minus 3 over 4, right? This is our simplified form. Okay, this is our restriction. So they both have to be in there, right? What's your restriction? Okay. That comes after the factoring stage, right? Factor first, state restrictions, then simplify. Okay. Question? Anybody still writing? Seeing none. See, negative 14 m squared minus 10m. Okay, go ahead, do this one. Okay, so we factor the numerator. I'm taking out the negative sign here, right? I don't know, I just like doing it that way. Nothing to do down here, just state the restriction. Check this, negative 14m squared minus 10m. So this sign was, initially I wrote it down as a minus, but it should be a plus, so you get negative 10m. Then you can cancel here, so we're going to end up with negative 1, and 2 goes into 14, so 7m down here. So it's negative 7m plus 5 over 7m. Okay, and then of course we can do this, right? Can't do that. Okay, can't do that. So you can't cancel these because this isn't, they're both 7m's, but this top expression is not really 7m. All right, let me get rid of those guys. It's 7m plus 5. So these can't cancel. Yeah, they look the same. Hey, I got 7m, but it's not a factor. Remember, factor is something that's out front. That's a factor. This is a factor. You can cancel them. This is not a factor. Right? Well, it is, but this is an expression. So if m were 1, this is 12 and this is 7. You never think of canceling these guys and say, oh, well, negative 12 over 7 is the same as negative 5. Because if I just cancel these guys, I get negative 5, right? And the 7m's are gone. So if you're thinking of canceling something and you're not really sure, should I be canceling those 7m's? Then just try it with the number. Right? And just say, will I get the same result? If I cancel those guys, I'm going to end up with negative 5. It says, well, that's always negative 5. You say, but wait, if I make m 10, I'm going to get like negative 65 over 70. That's not negative 5. Okay? So, if you get an idea in your head that, hey, I can cancel these guys, try it with a few numbers to make sure that, yeah, you really can. Okay, one more easy one. Okay, so where are we? Should be able to do this one? Step 1, factor the numerator. Denominator is just there, right? So there's nothing to factor. Step 2, state the restriction. Step 3, cancel any common factors. Step 4, check. So, very Canadian question, right? Or answer. 4a plus 11 over 2a. Laughing in spite of yourself. I'm trying not to. That was just really bad. Okay, let's go on to, yeah, that's the easy stuff, right? I can ask you a little bit of that, but let's simplify a binomial. Okay, binomial numerator and denominator. I'm going to give you an easy yet hard one. So I'm already going to factor this. So there's a factored form, right? So that could have started out life as like 12x minus 3x squared over 18x minus 72. But I factored it for you. First step, because it is factored, first step then is restriction, which would be what? X cannot be. Yeah, so x cannot be 4. Right? If x were 4, all manner of disaster would result. Right? The number would be 0. You'd be trying to divide by 0. You can't do that. Okay, is there anything that cancels here? 3 going to 18? All right, well, so that cancels, right? Is there anything else that cancels? You think about it, you say, you know, they look the same, right? Except what? Well, I got 4 minus x, and then on the bottom I've got x minus 4. So how does 4 minus x and x minus 4 differ? Sam?
Well, they're opposites. Like the x is negative in the top one, and it's actually positive in the bottom one, so that's different. And just,
But then vice versa too, right? The 4
Yeah,
is
so
positive in the top, and
yeah.
so it's like they're the exact same things, but their signs are reversed, right? 4 is positive, x is negative, and down below x is positive, 4 is negative. Okay, so here's what we're going to do. This is the key. I've seen this. This comes out on the diploma, actually, right? This particular thing we're going to do. We could do these, right? That's a 1 and that's a 6. So I can write this. So we've got 4 minus x over 6 times x minus 4, right? On the x up top, right? Yeah, sorry. Okay, here's what I'm going to do. I'm going to take that, I'm going to write it this way. Now, step 1. Go through the top and just verify for yourself that, yeah, those really are the same. So is x times 4 minus x the same as negative x times x minus 4? They are, right? So what did I do? I factored a negative 1 out of the numerator. Right? And in doing that, I said, if I'm going to put a negative out in front, then I have to change the sign of everything in that set of brackets, right? And now what happens? I have a common factor of x minus 4, which cancels, right? So these guys cancel. So if we're looking at it, we say, hey, these guys look the same, but they're just exactly opposite, right? And exactly opposite means I can't have 4 minus x here and then down here have x plus 4 or something, right? Saying, well, that changed, but then, wait, x plus 4, yeah, I can't have that because I need the negative. What I have to have is that there's a positive 4 here and negative 4 here. There's a negative x here and a positive x. Right? They both have opposite signs. If that's the case, I factor out a negative. I flip both of these signs. That becomes negative. This becomes positive. And now I say, hey, those factors are the same. Okay. Now, if I see this, I can also do this. Right? I could just cross this off, write in a negative 1. Okay, so I could say, look, I know that these guys are going to cancel with each other, but when they do, I better have a negative 1 as a result, not 1 over 1, but negative 1 over 1. Okay, so you can do that. You will see that. Okay, so opposite, exact same two terms, but opposite signs. So watch for that. Give me another one that's, I'm going to give you another factored one. Okay, so this is factored, right? So the first step then is the second step, which is state the restrictions. What are the restrictions? -2/3, which is what you meant to say. Is there any other restriction? 0. Okay, now some of you are looking at that going, huh? Like, hang on a second. So remember, we're looking down here, right? So we say, look, if x were 0, then this term is going to be 0 and the whole thing will be 0, right? So x cannot be 0. And then we're going to say, well, 3x plus 2, you know, if that were 0, then 3x would equal -2, and x would equal -2/3. And that's the non-permissible value, which gives you this restriction. Okay? So feel free to do this if you need to, right? To just say, what value of x is going to make 3x plus 2 equal to 0? So this is the hard way. I'll show you the easy way in a sec. So hard way, just solve it, right? 3x plus 2 equals 0. 3x equals -2. X is -2/3. By the way, if I tell you that a restriction is this, and I say, so what's the factor that goes with that restriction, right? Here's the restriction. X cannot equal -2/3. You just do this backwards. You just set x equal to -2/3. You multiply both sides by 3. You add the 2 to both sides, and you just say, okay, you gave me this as a restriction. The factor is the thing that's going to make that equal to 0, right? So we just multiply both sides, just rewrite it as so that it's equal to 0. Get this side to be a 0. And this, whoops, is the factor that gives you this as the restriction. This is the factor that gives you this as the non-permissible value, which you then write as a restriction. Okay? So there are two restrictions, right? X can't be 0, x can't be -2/3. When I ask you for restrictions, you have to give me all the restrictions that there are, and don't give me any ones that aren't restrictions. Just thought I'd throw this one in for the heck of it, right? You can't do that. All right, simplify it. What does it work out to? Okay. Take a moment. Shouldn't take too long. What is it?
That's it. 2x plus 3
Over?
over 3x plus 2.
You got it. Common factor was 8x squared, that cancels off, right? It's already done its job. Its job was to give us the restriction, which is x can't be 0. Once that's done, we say, hey, the same term top and bottom, right? Common factor, cross them off. That's step 3, right? So step 1 was done, it was factored. Step 2, we stated the restrictions. Step 3, we crossed off the common factors. What are you left with? And 2x plus 3 and 3x plus 2 involve the same numbers, but they're not the same expression. What do we got? 1, 2, 3 more. We'll do 3 more. C, 3x squared minus 15x. Okay, now we have to factor. This is not in factored form, right? So step 1 kicks in. So, your job, go ahead. Factor the numerator, factor the denominator. The instructions for any of these questions will be the word simplify. What you will see on the exam is, when written in simplified form, the expression blah is, and then you got like 4 choices, right? The multiple choice you know, the beginning part of the question would say da 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 is, and then there's your four choices, A, B, C, D. Okay, is that your factored form as well? What's step 2? Restriction, which is? So what do I write? X cannot equal 5. Okay, then what? Now sometimes if you're going to cancel in place, sometimes you lose terms, right? I think I did one earlier and I left out the x and you said, hey, there's an x up top. Okay, so if you're going to cancel in place, watch what you're doing. Usually what I'll do is this, just sort of, if I'm going to cross off, I'm going to cross off the 3x and say the 3 goes into the 6, but I'm left with an x. And the 6 becomes a 2, and this is just a 1, so we get x over 2. And what that says is for any value of x, except for what? 5, these two expressions will be equal, right? This is much easier to do. If I said you're going to do like 20 of these, I'd rather divide by 2 than I would be sitting there going 3 times and squaring the numbers, sitting with my calculator, punching it in, probably making a bunch of mistakes because I'm trying to do it on my calculator. You know, it's better to come up with the equivalent rational expression. Right. What do you say? 2 more? Let's go to a new page. It's only virtual paper. Step 1, factor numerator, factor denominator. So you're looking at a lot of common factoring, right? And that's what's going on in that top expression, right? It's just common factor. There's 2 terms, you're gonna have common factor. What is it? What is the common factor? X squared, okay? What does that leave me with? Okay, on the bottom. Okay, it's factored, state the restrictions. What's the restriction? What x can't be? Just 5? So 1 minus 5x equals 0. Negative 5x equals negative 1. X equals what? So what am I writing for restriction? Not 5. Go ahead, stick a 5 in there. What do you get? 1 minus 25. What's that? Not 0. I never wrote this in, but that's what it is. Do me a favor, college calculator, go 1 minus 5 times 1/5. If it's not 0, tell me. Right? I mean, literally, that's, you know, you might want to be doing that on the test. So you know one thing now about these quizzes, right? It's not like, okay, they don't take a whole lot of time. So if you're sitting there and you stick a 5 in there, then go ahead, pull out your calculator, go 1 minus 5 times 5, enter, and say, wait, it's supposed to be 0. And then go and write this somewhere and solve this, and then go 1 minus 5 times bracket 1 divided by 5, and hit, and if it's 0, then you've got it right. So check your restrictions, right? What does it take to check a restriction? Like, you know, you want to get 3.5 out of 4 because you got one restriction wrong on the whole page and you handed it in 30 minutes early. And now it's like, oh, you know, I could have had 4 out of 4, right? Been done with this and not have to worry about it. Now I'm going to have to reassess it if I want to get a higher mark. Now what? Got 5x minus 1, got 1 minus 5x. What's the final answer? Just write it down. Write down what you think the final answer is. Could be this. You could just be looking at it. It's just exactly what you got right there. What's the final answer? Okay, I got the exact same two terms, right? I got 5x minus 1, but on the bottom I've got a positive 1 and a negative 5x. And we just saw, hey, I can cancel those as long as when I do, I change one of them to a negative 1. Right? So I can cancel them. Because what I could do is put the negative, so what I could do is write negative x squared and then go 1 minus 5x. So I could do that. I can change the top expression into the bottom expression by putting a negative sign out front, bless you, which says change the sign of everything that's in the brackets, which means that it becomes a negative 5x and a positive 1. Let's write that as 1 minus 5x. And then these guys are now exactly the same. And they cancel. And we're left with negative x squared. Okay, so watch for that. You're going to see it. All right, last one. Then we'll just take a look at the key ideas. More than likely, you're going to have to factor a difference of squares on the diploma and on any quizzes and on the midterm and on the in-class final. And on the field test, and on the other field test, it's not going to count for anything, but you can use as a warm-up just prior to the actual exam itself, because we'll do it the day before. Nobody's writing Chem 30, right? Okay, perfect. So I'm going to arrange for a 3-hour field test the day before Chem 30, which is, or sorry, the day of Chem 30, which is the day before our exam. We'll do it in like 3:10 for a couple of hours, then we'll come in here and sit down and discuss the whole thing, go through question by question, until you're happy that you have it, and then, you know, the day your marks come out, the internet won't be on in the school or anything. I'm trying to find my mark. School internet. Okay, what's the factored form of the numerator? So it's a difference of squares, right? You're going to have to factor a difference of squares, I guarantee you. I'm going to write questions this weekend. I'm writing questions that will appear on future diplomas. Like, not for a couple of years, but for sure there will be factoring a difference of squares in there. Right? Always is. What's the next step? What do we do now? Restriction? -5. Now? Question that they really like asking is give you something a little more complicated than this and say, you know, so-and-so solved this problem and they made a mistake. And the mistake occurs in which step, right? You're going to get a whole pile of steps and it's going to be like step 1, step 2, step 3, step 4, step 5. Now, that might differ from the way that we do something in class, so you're just going to have to kind of follow through the steps and see what it is they're doing and where it varied and say, hey, it doesn't look like how we solve these problems, but it's still a valid method of solving it, right? Because teachers are writing these questions and everybody teaches their classes a slightly different way of doing something, and you're just going to have to adjust to that and just say, okay, they're doing it by this other method. Let me look through it and see what's one. Key ideas. A rational expression can be simplified by factoring the numerator and denominator and dividing both by their greatest common factor. Need to know, rational expression is in simplified form when the GCF of the numerator and denominator is 1, right? In other words, nothing goes into both of them. It's not like you have a 2 up top and a 6 on the bottom, you haven't simplified it. The non-permissible values must be stated before the rational expression is simplified. to ensure all restrictions for the variable are included. Like I say non-principal, we say restrictions, right? So you're always just going to see restrictions which are of the form x cannot equal whatever.